The second form of our quadratic function is probably one, like we said, would be more likely to encounter. It's just the ax squared plus bx plus c. More like we've seen in the quadratic formula, but now in the context of a function. Yeah, and so a, b, c, like in the quadratic formula, but this a is just like the a in form 1 we talked about. That's going to determine whether it opens up or down because it's times the x squared there. So now there are a few other things. Unfortunately here, you can't just read right off of the equation there. You can't read the vertex right off of it like you can in the other form. So, but we'll talk about that. I don't think the book actually gives this one a name. Let's just call it basic form because that's that's just a basic quadratic expression right there. But it's not an official name, I guess. All right. So yeah, we know it's still x squared, so it's still a parabola, and it's still going to be shifted off of the 0, 0 vertex, but the a still determines. If a is greater than 0, it opens up. A is less than 0, it opens down, so that's the same. So that's good news there. But here's how we get the vertex off of this, and we could go through it and figure out why it is, but here's how we get the vertex. I call it the vertex formula. And fortunately, it's a little easier than the quadratic form. You don't have to go through the quadratic formula or anything, but it's here's what it is. Turns out the vertex, h comma k, so defined h comma k, that's our vertex and our standard notation for the vertex. First of all, we compute h. H is going to be, turns out it's going to be negative b over 2a. Negative b over 2a. If we calculate that, so we're going to take whatever b is, negate it, make it the opposite, and then divide it by 2 times the a. That's going to give us the h of the vertex. That'll be the number, that's the h. Now for k, well, if you think about it, h is an x value, and k is a y value. So if I've got my x value, how do I find my, if I've got my x value, how do I find my y value? You plug it in, yeah. And so k, the way we find k is we plug in h for x. So let's just call it f of h. But that just means we're going to substitute the h value for x, and that'll be what my k value is. That's what that means, right? Substitute the h value for x and evaluate that, and that'll be your k. All right? Make sense? All right. And then we'll also talk about the intercepts, but nothing really new about those. We know how to do those. We'll talk about them when we need them. All right. So let's do a couple of these. Let's graph f of x equals x squared plus 4x minus 12. It's an x squared graph, so we know it's a parabola. And in this case, how does it open? Opens up, why?
It's greater than 0.
What's greater than 0? What's the a here?
1 squared.
It's 1, isn't it? There's no number in front of the x squared, so it's understood to be a positive 1. And so, yeah, that tells me this thing opens up. Right? Okay. Now, to get the vertex here, Well, it's not in the vertex form, so I have to use this little formula. It's not terribly much. So the h is just negative b over 2a. So what is that in this case? What's the b?
Negative 4.
The b is positive 4, so negative b would be negative 4. B is 4, so the negative b would be negative 4. And then 2 times a, so a we already said is 1, so just negative 4 over 2, which is negative 2. The h value of the vertex is going to be negative 2. To get the k, like we said, we're just going to plug in, do f of negative 2. You don't have to necessarily write that, but that's what we're doing here. We're just going to plug in negative 2 for the x. That'll be our input value, and that'll be our k value. So that'll be negative 2 squared plus 4 times negative 2, and then minus 12. Compute that, and that'll be our k. 4 minus 8 minus 12. So it looks like k is negative 16. So my vertex is, h is negative 2, k is negative 16. So it's a little more work, obviously, than the vertex form, but it's just how this one is. Okay? All right, well, get our graph going here. A little longer y-axis down here, don't we? Negative 16, so 5, 10, I think. This could be on by 2s. Negative 16, there we go. And then negative 2. Oops, should put those on the other side. Negative 2, negative 16, that's my vertex. And so we can kind of see it opens up, so it's going to open up there. All right, but let's get a couple more here. And on these, actually I want you to compute both intercepts. Let's get the x and the y-intercept here on this one. The y-intercept actually is really pretty easy. It's going to be an easy computation here. My y-intercept, setting x to be 0, 0 squared plus 4 times 0 minus 12, what do you got? 12. Negative 12. So y-intercept's negative 12. It's down here.
Negative 4 would be negative 12 too.
So yeah, you'd have it 1 over negative 4. That's right. Get that one over here. So you do have a pretty good idea, but sometimes those intercepts are important, so let's go ahead, x-intercepts, so let's go ahead and get those as well. How do I get the x-intercept?
So y is 0.
Y is 0 for the x-intercept. Well, in this case, the y is f of x, so you just set the f of x equal to 0. And compute that, so that is factor, I think the ones I have you do are typically factorable, so for the x-intercept. You got minus 12, 4 in the middle, 6 and 2. Plus 6 and minus 2. So you got x plus 6 equals 0, so that's a negative 6 x-intercept, and then x minus 2, so that's an x equals 2 x-intercept. And so that's where my thing crosses the x-axis. Negative 6 and 2. Yeah. So just having a couple more points kind of confirms things. If I can try. Connect them up. Got it. Okay, question? Look all right? How about this one? F of x equals negative 2x squared minus 3x plus 5. Do the same thing there, graph, and all that good stuff. All right, this one's going to open, well, you got the A here is -2, so that one's going to open down. Our vertex, so we're going to use our vertex formula, H equals -B over 2A. So again, A is -2, B is -3, and so the way I look at that, yeah, you've got B is -3, so negative B would be +3. You do the opposite of whatever B is. It's -3. I'm going to do it that way too. And then over 2 times -2, so you got -3/4. Let's go with -0.75. Make it at probably a little easier to compute for most of us to put it in the decimal there. So how do we get the K? Well, we just plug that in for X, right? That would be the K. So it's -2 times -0.75 squared minus 3 times -0.75 plus 5. And if I plug that in, -2 times 0.75, -0.75 squared, and then minus 3 times -0.75 plus 5. 2.46875. So that's my vertex. I want to be exactly correct there. It's about -0.75 and -2.5, positive 2.5. Like I said, also on these, I'd get the y-intercept and the x-intercept. So the y-intercept, just set x to be 0. That's your y-intercept. Necessarily have to write all this down, but it is 5, right? The y-intercept. What about my x-intercept? Well, let's talk about it. So my x-intercept, I set y or f of x equal to 0. Yeah, with the a being negative there, my suggestion is to solve this equation, let's move these terms over to the other side and make the x squared term positive, so it'd be 2x squared plus 3x minus 5, right? Because I'd add the 2x squared, add the 3x, and subtract the 5. And then it's a little easier to factor. Like I said, most of these that I'm going to give you will be factorable. If not, use the quadratic formula. You have to, but these all should be ones where you can factor. Let's see, 2x, x. Then you got minus 5, so that's 5 and 1. I believe the 5 goes here and the 1 goes here. And it's a plus 5 and a minus 1 because that'll give me that, and that's minus 2x, and that's positive 5x. So you add those, you got 3x. Okay? And so you got 2x plus 5 equals 0, and x minus 1 equals 0. So subtract the 5 and then divide by 2 here. And then add 1, so you got x is 1. And so I've got my x-intercepts. 1 and -5/2. Y-intercept 5, my vertex, I think you got it. All right, so let's put all that in here. All right, what do we got? Vertex, -0.75 and about 2.5. So right about here, and then 2.5 is right about there. My y-intercept is positive 5, right there. And, oops, what I do? Something doesn't look right. Is it this?
Because I couldn't get that, but I don't know.
Is this what I've got wrong?
I couldn't get it.
Okay. Oh, okay, I see what it is. There's something didn't look right here. Just
I think it should be.
Just checking y'all to see.
If I'm doing it right, it was
Yeah.
6.125.
6.125.
I believe so.
I could insert a plus there. I forgot my plus when I did all this.
Maybe not. Hold on. That's negative. Should be. That's not right what I said.
I should just, there we go, plus, there we go. 6.125, yes. K is 6.125. Did everybody get that?
Yeah.
Switched over. Nobody said anything. You got to tell me these
You
things.
got it, yeah.
Oh, went too
I'm still
fast.
figuring.
Okay. All right, well, those things happen, as you know. All right, so the vertex is negative 0.756. So it's up here, which makes it a whole lot better with my y-intercept being 5. And my x-intercepts being negative 5/2 and 1. There you go. All right. Any other? Everything else look okay? All right.
I just assumed I was wrong.
Oh, well.
I was like, I'll figure it out later. But
Yeah. If you can't get the answer, just let me know. It may be that I didn't get the right one. All right. Anything else? That look okay? All right, let's do one more, and I'll be done. Actually, I got one more thing after that. F of x equals 12x minus 3x squared. I do this one because they won't always be in the exact form that we may want them to be in. This is an x squared equation, but notice where the x squared is. It's over here. And so that, you may want to shift it back around, make it be in ax squared plus bx plus c form. So, yeah, let's do that just to make it clear. So it's minus 3x squared plus 12x, and then the c, I don't have a c, so the c is nothing, it's 0. C is 0. But in particular for these, the a and b here, be careful here, because the a is actually the -3, because if we said the a is 12, we'd say, hey, this parabola opens up, but actually the a is -3, right? And so this one's going to be opening down, parabola opens down. All right, so let's get my vertex. H is negative b over 2a, so that would be negative 12 over 2 times negative 3, negative 12 over negative 6, which is positive 2. H is 2, believe that. K then, I'm just going to plug in the x to be 2, so it'll be negative 3 times 2 squared plus 12 times 2. So that means K is negative 3 times 4, square the 2. And so that's going to be positive 12, 212. Here's my vertex. My y-intercept, easy enough. Plug in x to be 0. And so y is 0, yeah. The x-intercept, well, you let y be 0, x be 0, y be 0, f of x be 0, so that's negative 3x, 0 equals negative 3x squared plus 12x. This one we don't have to do well, we do factoring, but it's not the 2 binomial factor because this has a common factor, doesn't it? So you can bring those over if you want to, but this one's just going to be factor out of 3x. So it'll be minus x plus 4. Right? Yeah. So we got 0 and minus x equals negative 4, so x equals positive. So the x-intercepts are 0, positive 4. Is that okay? Now do those right. That's it. I'll mess up every once in a while just to see if we're paying attention. No, I just messed that up. Are those right? Everybody believe those?
Yes.
Good
No,
with
I
those?
haven't got the X done yet. but
Oh, okay.
I think so.
Looks okay. All right. Let's graph this thing. Graph opens down. Vertex is 2. Oh, 2 more. No. 6, 7, 8, 10, 12. 212. Y-intercept is way down here at 0.
0.
And then the x-intercept, of course, we got an x-intercept of 0, but we also have one positive 4. There's your parabola. Good? Is that okay?
Yeah, if you could leave it for a second though.
I will for a second.
Like on that one that you just did right now, where we're putting